Hello, my name is Shadi Hassan. This is my lab one for Physics 2212. These are what the slides are going to be about: the intro, fundamental principles, the lab observations, the calculations, the glossary of code and model, and the discussion questions. To introduce the lab, purpose is to find the amount of charge on a piece of tape to observing the exchange of electrons between two pieces. This idea is done by demonstrating a point charge, which is the tape, and assuming that the piece of tape is a distributed even charge. This charge is found through Newton's second law and third law. F equals ma in equal and opposite force. Coulomb's law can also be used, and these fundamentals can be used to calculate the charge. The dimensions of an atom can also be used to find the amount of electrons. The system of this experiment is two pieces of tape. The surroundings is everything else in the room. The initial is two neutral pieces of tape equal in length and one other piece on the table. Neutral tapes are ripped off tape on table and charged. The charge was confirmed by putting the tape in your hands, a neutral book, and a negatively charged pen. So this slide is a lab main experiment and the setup. The first diagram is the ripper, and the bottom is the main lab. There are two pieces of neutral tape which have separate ripping stations on the table to charge both. Tips are poorly charged. We're ripping them off the table. This either makes the tape gain or lose electrons. The first tape A, was taken and put onto the second tape, charged tape B. This made tape B float in the middle and go up a distance. Following data and information is recorded. These are the observations and measurements. The length of the tape, 0.291 meters. The mass of tape, which is 0.00219 kilograms. The width of tape, which is 0.0190 meters. And the distance between the tapes that are floating, 0.0285 meters. The magnitude of gravitational force, which is F grav equals mg, which is 2.148 times 10 to the negative 3 newtons. And the magnitude of electric force, which is the same as gravitational force, because the tapes are floating and motionless. Tape in the environment was attracted to the hand and repelled against another piece of tape. Tape was attracted to a negatively charged pen, meaning the tape was positive. These are the calculations for the experiment. So first, the charge of tape, which is 1.3925 times 10 to the negative 8 coulombs, which is found using Coulomb's law, and the amount of electrons, which is the charge of the tape over the electron charge. So 8.7 times 10 to the 10 electrons is the excess electrons on the tape. And the amount of atoms, which is found in the tape area, the area of the atom. So tape area over area of the atom is 4.16 times 10 to the 17th atoms. And the amount of electrons per atom, which is the amount of atoms over the amount of electrons, which is 4.78 times 10 to the 6 electrons per atom. So this is my glossary code with all the previous calculations and values. So PHYS, Q electron, tape mass, tape length. And some assumptions that have to be made for this model is that air resistance is negligible. A piece of a tape is assumed to be a point charge with all of its charge in one area instead of spread across the tape. And this makes it a little different because the charge was really distributed evenly throughout the piece of tape. So this is my model, the red sphere being tape B and the blue sphere being tape A. The green vector is gravitational force and the orange vector is electric force. The charge of one piece of tape is given 1.39 times 10 to the negative 8 coulombs. Excess of electrons given, and the electrons for every atom is also calculated in the code. So some potential errors for this model in the lab was unequal charges on tape from improper handling, and this means that the Q for each tape might have not been the same due to this. So this slide is the discussion slide. First question is, what if the electrons had positive charge and the protons were negative? The observations would actually not change because they would react the same way because they would still have excess charge, and they would react the same way coming into contact with other tapes and your hand and books, and like the charged pen would be positive instead of being negative then. So the results would not change. The observations would stay the same. And for the second question, you can't handle a tape for as long as like you want because some of the excess charge will go onto your neutral pen or neutral book and polarize it. So the tapes will lose their charge and won't repel or attract. And that concludes my lab.